Alright, so hope you're enjoying your day off. Alright, I'm gonna try to get this video up as soon as I can for the problems that are due tomorrow. Alright, exam review questions 41, 44 through 48, and 28. Alright, so we missed a lesson today. At the end, it's pretty important to get these lessons in, but well, let's get some problems done. All right, problem number 41. All right, we're dealing with the sinusoid again. All right, and I tried to split the sinusoids. If you look at the exam review questions, the days, the stamp sheet, tried to split them up and do like pretty much one a day. All right, Sarah's riding a Ferris wheel. All right, so this is one of those Ferris wheel questions. Her sister, Kari, starts a stopwatch and records some data. Let H represent Sarah's height above the ground at time t. Kara notices that Sarah is at the highest point, 80 feet above the ground, when t is equal to 3 seconds. When t is equal to 7 seconds, Sarah is at the lowest point, 20 feet above the ground. Assume that the height varies sinusoidally with time. Write a trig function, write a trig equation. All right, B, what will Sarah's height be at 11.5 seconds? All right, answer to 3 decimal places and determine the first 2 times. All right, t is greater than 0 when Sarah's height is 70 feet. Your answer should be correct at 3 decimal places. All right, so let's get started. All right, let's pull the information from the problem, similarly to what we did before. All right, so we have t is equal to at 3 seconds. All right, we are at 80 feet. And at t is equal to 7 seconds, we're at our lowest point, which is 20 feet. All right, so from there, let's that's pretty much enough information to get what we need. All right, let's draw the. Doesn't ask us to draw a graph, but I enjoy drawing the graph, so I'm going to draw the graph. All right, 1, 2, 3, 4. We're going to make that 80. We're going to make that 20. All right, 1, 2, 3, 4, 5, 6, 7. All right, to 7, 8, 9, 10, 11, 12. Let's go there. All right, so we said at 3 seconds, we're at 80 feet. All right, 4, 5, 6. Ooh. At 7 seconds, 4, 5, 6, 7 seconds, we are at 20 feet. All right, so we go from low to high in that time. All right, now if it takes 4 seconds, 3 to 7, to get from low to high, then it's going to take 4 more seconds. 1, 2, 3, 4. All right, that's 8, 9, 10, 11. 11 seconds to get back to the high. All right, and so looking at this part of the graph, we can kind of draw that in there. All right, there's your sinusoid. All right, if we go high to high, or our distance from high to high, we can see that our period, all right, is equal to 8 seconds. All right. Now, our max, big M, is 80. Our small m is 20. All right, and right away we can see that we're going to, if we do this, we're going to say positive cosine. Make this a positive cosine function. All right, so because they're asking for our equation, all right, we want to give them an equation. So from what we have here, let's see if we. All right, from here, let's get the trigonometric equation. All right, we want to go We want to figure out our D value. All right, and so we're going to say D is equal to M minus small m over 2. I'm sorry, A is equal to, sorry about that. A is equal to M minus m over 2. All right, that's going to give us 80 minus 20 over 2, which is equal to 60 over 2, and that's 30. All right, we're going to say D is equal to big M plus small m over 2. All right, and that's 80 plus 20 over 2, which is 100 over 2, and that is equal to 50. All right, from here, let's go with C. All right, and C is our phase shift. All right, and we want to take that first high. If we want to write a positive cosine function, all right, and if that's the case, then we go over to 3 seconds. All right, so our C value is 3 seconds, and then that leaves us with B. All right, in this case, B, or any case, B is equal to 2 pi over period. All right, and in this case, our period is the distance from high to high. All right, and that's from 3 to 11 seconds, all right, which is 8 seconds. So we go 2 pi over 8 is equal to pi over 4. All right, and we have everything we need, so let's write in an equation that fits our situation. All right, we say height h of t. All right, we say h of t because it's the height for some given time is equal to 30 cosine pi over 4 x minus 3, so we got A, we got B, we got C, plus our D value, which is 50. All right, so let's plug that in the calculator and see what we get. All right, see if we can reproduce this graph. All right, 30 cosine. Let's go, I'll put extra parentheses. Pi divided by 4, close, open. X minus 3, close, close, plus 50. All right, and before I hit graph, I want to change my window to look like the window of whatever you sketched. And sketches haven't been a problem this year. 0, enter 12. All right, 11, 12. So by ones. Y min is 0, and let's go to 100. All right, and we went by 20s. All right, and we see if we can get the graph. All right, looking good. All right, if you're not sure, you can go and check the answers that they give you. At 3 seconds, we're at 80, and at 7 seconds, we're at 20. So we know that this graph is a decent graph. All right, and then we can try to answer some of the other questions that are here. So question B says, what will Sarah's height be at 11.5 seconds? All right. So the easiest way to do this, I mean, you could plug 11.5 into the equation, but we put it in the graphing calculator. So we're going to go to second, calc, value. All right, and you're going to say, well, x, what happens to the height when x is equal to 11.5? All right. And it gives it to us, all right, right there at 11.5. All right, the height, so we say when, all right, that's A. For B, when the time is 11.5 seconds, then the height is 77.716. And what units are we using? Feet. All right, now that's 11.5. That would be somewhere right there. All right. Excuse me. Determine the first two times when Sarah's height is 70 feet. All right. So what we're talking about is if we're at 70, this is about 70. We want to know the first time and the second time. All right, that graph, the height reaches 70 feet. So we go to y equals. We type in under y2, we type in 70. All right, and you notice that it puts a nice horizontal line in there. All right, and we want to find this time and that time. All right, so in order to do that, we want to do intersection. All right, so we go second calc, and we have to do these separate. Second calc intersect. All right, I usually just, when it says first curve, I hit enter, and then I scroll over close to that first intersection point. All right, you can put it right on it or close to being on it. Don't want to guess, hit enter. All right, and it gives us an answer. All right, and it tells us that the first time, all right, the first time that we are intersecting a height of 70 is at 1.929 seconds. All right, and then you can do it all over again. Second calc intersect. First, I usually just hit enter on the first curve, and then it's easier to scroll over, get close to that next intersection. Enter. Don't want to guess. All right, and it is at, it takes 4.071 seconds. All right, remember everything in 3 decimal places. That's what we've been doing all year, and that's why, because that's what they expect on the final. All right, number 44 says, how many triangles ABC are possible if angle A is equal to 20, side B is equal to 40, and A is equal to 10. All right, and so this is one of those. If they're asking us how many triangles, it's probably a ambiguous case. All right, and we want to check that. All right, so let's draw this triangle. We're going to say that's A, 20 degrees. Doesn't have to be exact, right? But well, something close. All right, so A. We'll call that B. So that means that this is 40. All right, and side A is equal to 10. All right, and so in this case, we have a, all right, we have a angle side. All right, and anytime we have angle side, we're not sure. All right, you see angle side, we need to figure out the height. All right, we need to figure out the height. Now, in figuring out the height, we want to go, we say that our height is going to be equal to our adjacent side, the adjacent side, which you know. All right, sine the angle. All right, adjacent side, sine the angle. All right, and all that is using your SOHCAHTOA to figure out your height. All right, forget about this side, all right, because this side, we don't know if it reaches down here. All right, so the height of this triangle, H, is going to be 40, the adjacent side that you know. All right, sine 20 degrees. All right, so let's figure out what the height is. All right, in this case, let's see, make sure we are in degrees mode. Degrees first. All right, we go 40 sine 20 degrees. All right, hit enter. All right, and it's telling us that 681, that the height of this situation, or that triangle, would be 13.681. Now, imagine this. If this distance is 13 something, then this side right here that they told you would never reach the bottom. It would just kind of dangle. All right? All right, and what we say is that if A is less than the height, then we don't have a triangle, no triangle. And in this case we don't have a triangle. (45) Given triangle ABC, where angle A is 41, angle B is 58 degrees, and side C is 19.7 centimeters. Determine the measure of side B. Your answer should be correct to 3 decimal places. All right, so let's draw this triangle. All right, so I notice. Let me make that a little bit bigger. All right, so we're going to say that this is B, this is A, all right, this is C. All right, we're saying that this is 41 degrees. All right, this is 58. And side C is 19.7, all right, centimeters. All right, and so in this case we have angle side angle. All right, and in this case, well, if you have two angles, you ever have two angles, you got the third angle. All right, so we're going to figure out angle C. All right, angle C is going to be 180. All right, we know the sum of the angles of a triangle are 180 degrees. So we can figure out that third minus 41 degrees minus 58 degrees. All right, that's going to give us angle C. So we got 180 minus 41 minus 58. All right, and so we're saying that angle C is equal to 81 degrees. All right, got that going first. All right, now that we have that, we can use our law of sines. We have some little ratios there. All right, so let's use that. All right, and so we are looking for angle. Remember what they asked us to find. They asked us to find side B. All right, so we don't have to find side A, so we only have to do this once. All right, and so we say that we say sine 81 degrees over 19.7 centimeters is equal to, and since I'm looking for side B, I want to use sine 58 degrees. All right, and we're going to solve for B, so we cross multiply. All right, we can say B sine 81 is equal to 19.7 sine 58 degrees. All right, from there, divide both sides by sine 81 degrees. All right, and that gives us B is equal to all of this, 19.7 sine 58 degrees all over sine 81 degrees. All right, and in this case, B is equal to, let's see, parentheses, 19.7 sine 58, close, divided by sine 81, close. Alright, I'm going to check my mode, make sure I'm in degrees. I'm in degrees. Alright, and it tells me that side B is going to be equal to 16.915 centimeters. And done. Alright, number 46 says in triangle ABC, side A is equal to 9, side B is equal to 12, side C is equal to 16. What is the measure of angle B? Alright, your answer should be correct to the nearest tenth of a degree. Alright, now if you look at the front cover of your formula sheet, the law of cosine that they give you has the angle C. Alright, so we need to change this around a little bit to fit us. So the one that they give you is this. Alright, and so we're going to use this, but we're going to change it around. Alright, before we do that, let's get the triangle. Alright, so let's just draw a triangle here. Alright, let's say that this is my triangle, this is my A, BC. Alright, and they give us 9, 12, let's say 9, 12, and 16. Alright, and it doesn't have to be the scale, but we see that we have side, 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 and when we have side, 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 we're going to use law of cosines. Alright, excuse me. So what we want to do with that equation is change it around to use the angle that we are looking for. Alright, and in this case, we're looking for angle C. I'm sorry, angle B. Alright, and since we're looking for angle B, in this case we would use angle C. Alright, so anytime that's the case, we go, well, if I want to use find angle B, then that means that the other values inside here have to be A and C. Alright, so that's we say B squared plus, oh, look at me messing up already, sorry. Alright, again, A squared plus C squared minus 2AC cosine B. Alright, and that's B squared out in the front. Alright, and so that's what we want to use if we're solving for angle B, and that's what we're solving for in this problem. So let's keep going. Alright, plugging in, B squared, 12 squared is equal to A squared, which is 9 squared, plus C squared, which is 16 squared, minus 2 times 9 times 16 cosine B. Don't know it yet, but there's the formula. Alright, now finding our squares. Alright, this is going to give me 144 is equal to 81 plus, what is this, 256 minus 2 times 9 times 16, that's minus 288 cosine B. Alright, let's see, 81 plus 256, alright, gives us, so we have 144 is equal to 337 minus 288 cosine B. Alright, I'm going to subtract 337 from both sides. Alright, that's 144 minus 337. All right, that's going to give me a negative 193 is equal to a negative 288 cosine B. All right, divide both sides by, oh, we're still on the screen here, a negative 288. That is cosine B. All right, so I'm going to just leave this as 193 over 288 right now. All right, and then from there, I'm going to find out what angle B is. So we say B is equal to the inverse, because remember we're looking for an angle, so we're going to use that inverse key. All right, cosine inverse of 193 over 288. All right, so inverse cosine 193 divided by 288. All right, I was in degrees, yes. All right, and so my angle is 47.922 degrees. Since it said give the answer to the nearest 10th degree, this is 47.9 degrees. All right, problem number 47, determine the remaining measurements of a triangle with angle A being 58 degrees, side A 11.4, side B 12.8. Your answer, sides and angles, should be correct to the nearest 10th. All right, so let's draw this. Let's get a good picture of this, because we're going to slice it up probably. All right, so we'll say that's A, which means side A is 11.4. All right, I'm going to try to get a better picture of this. All right, 11.4. We're going to make this B. So side B is 12.8. All right, and this is C, side C. All right, and we know angle A is 58 degrees. All right, and so this is the picture that we have. All right, probably not exact to scale, pretty good. All right, and so what we see right away is that we have angle, side again. All right, and when we have angle side, we're not sure if we have a triangle or not. All right, we need to figure out whether or not we have a triangle. All right, so the first thing we need to do is find the height. All right, and again, finding the height is going to be the adjacent side sine the angle we know. All right, so the height in this case is going to be 12.8 sine 58 degrees. All right, and so the height is 12.8 sine 58. All right, let's make sure we're in degrees, yes. All right, enter. So our height is 10 point, okay, I guess we can do an, all right, so we have a height of 10.9. All right, now, if the height, all right, anytime that A is greater than the height, we have two triangles. All right. All right. So we have this big triangle we see. All right, and we also have the triangle where this angle and this angle are the same. All right, what we have over here, we basically take away the isosceles triangle. All right, so we have this triangle right in here. All right, so we have two triangles in this case because basically our opposite side can dangle. All right, it can go, if it's reaching this, what we would consider a base right now, it could be here, or it can go all the way through and back over to here. But this side is also 11.4. All right. The good thing about this is that once we find this angle, all right, this angle right here is just 180 minus the angle we already found. All right, so we're going to take care of the big triangle first. All right, let's take care of that big triangle. All right, I'm going to erase this right now. All right, and so we call the big triangle triangle 1. All right, we have these values in black. All right, and we can go sine 58 degrees over 11.4 is equal to sine angle B over 12.8. All right, using our law, that's our law of sines. All right, if we cross multiply, all right, that'll give us 11.4 sine B, all right, is equal to 12.8 sine 58 degrees. We'll divide both sides by 11.4. All right, that gives us sine B is equal to 12.8 sine 58 degrees all over 11.4. All right, and then we're looking for that angle measurement. We're looking for angle B. All right, and so we say inverse sine. We're looking for an angle measurement, so we're going to go inverse sine of all of that. 12.8 sine 58 degrees all over 11.4. All right, and let's see what that gives us. All right, inverse sine 12.8. Let's put another parentheses in here. Put our numerator in a parentheses. Sine 58, close, divided by 11.4. Right, and then close. All right, and so it tells us that B is equal to 72.2. All right, 72.2 degrees. All right, now, if that's the case, where this is 72.2 degrees, we can figure out the rest of this triangle. All right, so let's go ahead and knock out the rest of this triangle. All right, 72.2 and 58. All right, we're going to figure out angle C first. All right, so angle C is just 180 minus 72.2 minus 58. 180 minus 72.2 minus 58. All right, that's going to give us an angle C value of 49.8 degrees. All right. All right, and then what else do we need? Well, we need side C. Side C. All right, and so side C, we have to use law of sines. All right, and so we're going to go, let's see, we can go sine 58 degrees over 11.4 is equal to sine 49.8 over side C. All right, we cross multiply, that gives us C is equal, C sine 58 degrees is equal to 11.4 sine 49.8 degrees. All right, divide both sides by sine 58 degrees, so we say C is equal to 11.4 sine 49.8 degrees all over sine 58 degrees. All right, that's parentheses 11.4 sine 49.8 close divided by sine 58. All right, and that tells us that C is equal to 10.3. All right, and so for this problem, the information we found is this, this. All right, so that's all for one triangle. I know you're like, good gracious, there's a lot of work here. All right, but if we go back and look, now we have to look at that obtuse triangle. All right, we call this the acute triangle because this angle we found was an acute angle, but this angle has to be an obtuse angle. All right, so let's start with what we found. All right, so in this case, and it should be a little bit shorter. All right, angle B, the second angle B, which would be right here, and it would be this triangle. So let's draw that triangle. Let's take it out of here. All right, looks like this. Right, and the values we have are 58. All right, we don't know this yet, but we're about to find that. We know that this is 12.8, and we know that this is 11.4. All right, so let's our B. All right, our B is equal to whatever we had before. All right, it's going to be 180 minus what we had before, 72.2. All right, and so our B in this case, 180 minus 72.2, all right, is equal to 107.8. 107.8 degrees. All right, that's our new B. All right, or our second triangle B. All right, so we have that. All right, which means that we can find angle C, and we're just following these steps now. We can call this, let's just call this the second angle B. All right, now if that's the case, we're going to need to find the second angle C. All right, and so we're going to do what we did before. We know 2 of the 3, so we go 180 minus 107.8 minus 58. Right, it should be pretty small, right? 180 minus 107.8 minus 58. All right, and so the second angle C is equal to 14.2 degrees. All right, and then that leaves us for one more thing, right? 14.2. All right, that leaves us with side C that we need to find. All right, small c. All right, and so we go back to law of sines, and we can say sine. Right, we can say sine 58 degrees over 11.4 again is equal to sine 14.2 degrees over small c. All right, side C. So we cross multiply again. So we're going to go C sine 58 degrees is equal to 11.4 sine 14.2 degrees. Divide both sides by 58 again. All right, and so in this case we're saying that the new C, or the second triangle C, is equal to 11.4 sine 14.2 all over sine 58 degrees. All right, and so in this case, let's do that. 11.4 sine 14.2. All right, divided by sine 58 degrees. All right, and that gives us an answer of 3.3. All right, and we found everything for triangle 1 and everything for triangle 2. And we're done. A lot of work, right? All right, for number 48, looks like we're dealing with just regular right triangle stuff. So we're, let's draw the picture. All right, it tells us from a point 200 feet from its base, 200 feet from its base. All right, a lighthouse. Not gonna get fancy here. All right, a lighthouse. The angle of elevation from the ground to the top of the lighthouse is 55 degrees. All right, so that's not quite 55 degrees, but we're going to take it. All right. All right. How tall is the lighthouse? All right, from a point 200 feet away. So there you got your 200. All right, you have your 55 degrees. They want to know that. All right, and so once again, here we go again. It's a right triangle. All right, and if it's right triangle, this would be a question where we're dealing with SOHCAHTOA. All right, any of that stuff would help us. All right, we know the adjacent side. All right, and we're looking for the opposite. All right, so adjacent opposite, SOHCAHTOA. All right, SOHCAHTOA, however you say it, we would use, you're right, tangent. All right, so doing this problem, we're going to say tangent, or tan, 55 degrees is equal to opposite, x, over adjacent, all right, 200. All right, and we're going to solve for that x, and that'll tell us the height of that lighthouse. All right, ready? All right, so we can start by multiplying both sides by 200. All right, that gives us 200 tan 55 degrees is equal to x. 2 tan 55 degrees. All right, and so that is letting us know that, and it's to 3 decimal places, that our lighthouse is 285.630, and that's feet. All right. The next problem, and this is the last problem. All right. I kept the problem number 29. If I was making this review, I think I would put problem number 29 before I put problem number 28. I know we don't have to do 29 right now, But if you remember, if you can remember that what the identities, the inverse functions are, then it's easier to figure out the domain. All right. Now, if you remember, if we're looking at y is equal to sine, all right, when we're looking at the inverse, we're only looking at the inverse from pi over 2, all right, to negative pi over 2. All right, when we're looking at inverse tangent, we're looking at the same values, pi over 2 to negative pi over 2. All right, first and fourth, but connected. And then when we're looking at inverse cosine, we look at first and second quadrants. All right, and that'll give us our values. All right, so we look from 0 to pi for our answers. All right, now, when we look at this, we know that the one that has the asymptotes is tangent. All right, so we're kind of doing problem number 29. All right, the one with the inverses is tangent, so this is tangent inverse. All right, this one, both of inverse cosine and inverse sine both go from -1 to 0. All right, but inverse sine values are from negative pi over 2 to pi over 2. All right, and cosine inverse or inverse cosine values go from 0 up to pi. All right, and so this will let us know that this one is inverse cosine. All right, and when we do this problem later, we'll do a better job of explaining that inverse sine. All right, so if we look at these graphs, all right, these graphs correspond to number 29, which is what we're doing right now, and it's 29 really. All right, and number 29, if we look at our domain of sine, it goes from -1 to 1, all included, so it's -1 to 1. All right, your range, lowest value, top, highest value, bottom value, highest value is negative pi over 2 to pi over 2. All right, cosine. All right, domain is -1 to 1, including. All right, and your range is from 0 up to pi. All right, and then tangent. Well, look at tangent. It keeps going to the left, it keeps going to the right, so it's all real numbers. All right, and if you would like to write, I guess, from -infinity to infinity, you can. All right, either or works. All right, now it stays between -infinity. I'm sorry, negative pi over 2 and pi over 2, but it never hits it because of the horizontal asymptotes. So instead of a hard bracket like these, we will give it the not included bracket. All right, solve. We'll say negative pi over 2 to pi over 2. All right, and that's your answer for number 28.